Hey guys, welcome to the basement workshop and the introduction to a new projects. No, you're not seeing double. I have two RCA television chassis out here on the floor because I want to look them over briefly and then get one of them up on the workbench, but I do intend to work on both of them at the same time. So these are late 40s RCA chassis, the successor to their flagship chassis they used in the RCA 630 TS. Now I restored one of these last year that went in my RCA 8T241, and that also came out of an RCA 8T241. I don't think these are exactly the same model number or chassis number though. That one I haven't found yet because it's kind of corroded, but this one is a KCS 34B 10-inch 12-inch tabletop console, and this is the type where the CRT is mounted to the cabinet. But this, I don't think I've seen this before, where it's an RCA where the using this chassis where the CRT is mounted right to the chassis. It's a 12-inch. So I imagine there's some slight circuit differences to accommodate the larger CRT size. Otherwise, they look to be pretty much the same. Now, this chassis in particular has some sentimental value to the owner. It's a little rough, both the cabinet and the chassis. And as I'm looking from the underside for the first time, I can see something that's definitely very concerning to me, which is blue-greenish corrosion under that bar. That's one of the peculiar things to these early RCAs, be it the earlier incarnation of this chassis or this incarnation. These huge things on the back. What are they? They are bleeder resistors, voltage dropping resistors. If you watch my series on Beginner's Guide to Vintage TV, I talked about an Admiral TV, in particular the power supply. They had two power transformers, two rectifiers, two filter chokes. So because these early black and white sets typically used two power supply rails, one for the deflection circuits, one for the IF. Admiral did it with two power supplies independent of each other. RCA took the different approach where they have one huge power transformer and then sometimes dual 5U4 rectifiers, and then a huge voltage divider. So this is a giant resistor with taps on it for different voltages, and it gets really hot, so that's why it's outboard. It's mounted to the back of the chassis. This one visually looks okay. That one, maybe not. They are not the easiest things to replace, because of course you can't buy something like that these days. So you got to get individual power resistors and mount them somewhere. Drill some holes on the chassis, use some thermal grease, string them together. I may be doing that on that one. But the main focus of this video, I think, is going to be this guy, because I want to try powering this up. This one, no. It's got too many issues. It has corrosion, and there was some rodent activity, but we'll look it over. Look for any other troubling signs besides that power resistor. I cleared off enough space on the workbench to get one of these up here. This is a nastier one. I think it's a KCS 28. Looks like 281, but that can't be right, so maybe it's 28-1. Anyways, this is the one he's more interested in getting working, but this is the one that's far nastier. So there is crud and corrosion all over the top side. We've got some other issues too. There's supposed to be I guess it's a leather belt that goes between this and this, with a tensioning spring on it. That's your fine tuning. That's just gone. It's supposed to wrap around so you can have a fine tuning knob here, and it goes around and it rotates this up here, which goes to a piston down there. Moves a slug up and down. So we've got to replace that with something. The cover for the high voltage box was missing, but I saved one years ago, just thinking I might need it someday, so I have that. Here's a look at some of the corrosion I gotta deal with. So maybe while I'm working on the other chassis, I'll throw some navel jelly or something on that. Can't exactly dunk it in a bucket of evapor rust. Well, the bigger concern to me is not just surface corrosion. It's that when you get rodent activity, they can chew on wires, they can chew on transformers. And that corrosion on the back, that we could have open windings. In particular, I'm concerned about that guy. When I restored this chassis last year, that guy was open. I have one parts chassis and I scavenged that out of it. I don't have any more spares. That is a vertical oscillator blocking transformer. Without that, you don't get vertical deflection. So we got to hope that's good. The rest of it, yeah, like I said, I have a parts chassis, and I think any other part I could replace, except for that guy. Alright, so that's top side. Let's take a closer look underneath. See if anything's been chewed up. Not too bad. What really got me concerned was in the cabinet. There's a cutout for service access, and there should be a metal mesh over it that was gone. So there was nothing preventing any critter from getting right in here. So, yeah, a little bit of mildew on some of the caps. So this bumblebee's wheelie looking. It's probably been oozing its insides out. But the important thing is I don't see any chewed up wires. So it's actually nowhere near as bad as I thought. So I think our main problem is going to be this guy. Even if it measures okay, I don't think I want to use it. So once those start corroding, they're liable to go open. Alright, so as you can see, it's typical RCA of the era. It's built like a tank. There's a ton of caps to replace. But there's very, very detailed service info available both from RCA and the same as PhotoFax, so we shouldn't have any trouble with this. Looks to be all original. Excellent. Alright, here's the other one. It's rotated 180, but otherwise looks basically the same, except it's in a heck of a lot nicer condition. In fact, this is in really, really good condition. And sure does appear to be 100% original. Fantastic. Don't see anything that concerns me whatsoever about trying a power up. Just flip her down and take a look topside, make sure there aren't any loose connections or missing tubes or anything. We only have one obvious loose connection, high voltage CRT. Don't worry, it hasn't been turned on in decades. I'm not going to get shocked by anything. Go. What? Pray tell is this? I don't know. It looks like this should go. Oh, somebody defeated it. Switch. I bet this was. I can't remember if this came out of a console. Maybe it has doors on the front. But this is a kill switch, or was until somebody disabled it. So in other words, if you close the cabinet doors, it would turn the set off. That kind of thing. All right. Let's see. CRT is disconnected from when I was testing it. The original RCA Victor. Base is slightly loose. We'll go around and make sure all the tubes are seated. Other than some light surface dust, quite a bit different than the other chassis. I guess we should take a peek inside the high voltage box before we move on. And also here is what that missing belt. Here's what that missing belt should look like. So you can. Oh, this one is broke, or it's about to break. Certainly not moving anymore. I think a heavy-duty rubber band might be able to work. Figure something out. Something else, original power cord must have gone bad and they just ran one right through the chassis. Right into the horizontal linearity coil, geez. Okay. I have replacement cheater cords. I can do a better job on that. I hope they didn't damage the coil from jamming that in there. Let's see, a pilot light for the cabinet and speaker. That all looks okay. We'll place bets on whether or not the 1B3 is any good or not. I've been running into a lot of bad ones lately. Alright, so last thing I'll do is I'll check how this power cord is hooked up, and if it looks okay, I'm going to try to power this up. Alright, it's crude, but the power cord actually looks to be wired in okay, so we're good there. I popped out the 5U4 rectifier, so we're power this up. Alright now, here we go. Power switch is in the on position, so we got juice going to the set right now. And we have lights. That little pilot light must be burned out. Oh, wait, no, there we go. Just corroded. We'll have to work on that. Alright, well that's cool. So you know what comes next. Turn down the Variac, put the 5U4 back in, and go slow. I've been steadily ramping up the voltage. We're at about 85 volts in. We're drawing about 1.5 amps. This set draws 2 amps. It's right in the back. 115 volts, 230 watts. So that'd be 2 amps at 115 volts. And check this out. Our old trick. Hey, that means this is doing something. No light in the face of the CRT, but I wouldn't expect that quite yet. So I have no idea how the controls are set. So, onward and upward. Got a little bit of blue glow on the side of this BG6. Looks kind of cool. It's not a bad thing at all. It's just a stray electron sitting in the glass. Makes a neat effect. A lot of the tubes appear to be original. The one that's the RCA Victor would be original. Some are replacements, but they're still RCA. Oh yeah. There you got a lot of power going through there now. I expect maybe now we could see something on the face of the CRT. Nope. You know what that means? We could have a bad high voltage rectifier. Would not surprise me in the least. Before we go there, let's get this up a little bit closer to its operating potential. Well, actually, we're pretty close to it. I'm at 100 volts now. I'll go up a little bit higher. And I'm going to turn this thing around, or at least 90 degrees, so I can see the front of it more readily as it adjusts controls. Right now, yeah, absolutely nothing. Alright, let's shut her down and see about replacing that tube. I don't doubt there's going to be any charge on there. I think it's cold. Not that these get all that hot, but I think it'd be a little bit of warmth with the filament had been glowing. I didn't see it glowing either. It's an RCA 1G3, 1B3. It's not the original though. It's slightly newer than the set. Don't see a date code. Alright. Put out the call again. I'm looking to buy a whole bunch of good 1B3s. As Shango and I were discussing a little bit the other day, we may have to start making solid state replacements. If we can't secure a good reliable set of these. What he's speculating is that these go bad because the seal around the cap up top goes bad. Sounds plausible to me. Let's see if I can scare up a good one. Aha! 3 new old stock Sylvanias. I've been working on another project on the side you guys will soon see. And the owner of that side had a little stash of tubes that he sent me. Oh! Man. I hate that. Nice set of new boxes. You figure you have new tubes inside, used tubes inside. At least that tube is used. Been fooled so many times. Alright, that's a new tube. That's a new tube. Warning, said voltages may produce harmful X-rays unless tube is shielding. Alright, let's get some X-rays going. Kind of a myth. These sets don't run enough voltage to produce X-rays. Certainly not hard X-rays, soft X-rays. It's like 9,000 volts. You get up to 30,000, yeah, maybe, but not at this voltage. Anyways, here we go. Peering under the voltage rectifier to see if I can see a glow. Kind of heard something like high voltage kicking in. Most of them on the face of the CRT. Get that going for us. Move the ion trap magnet a little bit. Certainly no guarantee it's in the right spot. No, that's not doing jack. Alright, it's time to rotate the set around so I can get the front controls more readily. Hang on before I do that. The high voltage filter doorknob cap is really easy to get at right there. So let's get out a high voltage probe and just try to measure it. So this will be a filter cap on the output of the 1B3 voltage rectifier. Chassis is grounded, so we can just clip right to that. And let's see. .600 volts. Nothing. That's a little disappointing. I'm surprised I'm not getting anything much on this either. So this is where things are at. Sector voltages on a 6BG6 and horizontal oscillator, control, tube, everything's dead on. I am looking at the waveform on the grid of the horizontal output tube, 16.75 kilohertz, give or take, Amplitude, I don't know, because unfortunately in the service info I have, there are no waveforms. But the grid on the voltage seems to be right, and if I adjust the drive, I can increase and decrease the amplitude on that signal. So the horizontal oscillator is running. It's on frequency. The amplitude seems reasonable, I think. But we have virtually no high voltage, so could be an issue with the damper tube. It's on a little island, and I can't easily measure. When you're not supposed to measure most of the voltages on it anyways, because it's some pretty big spikes. So I'm not sure about that. I can swap it out yet again, or it could still be that 1B3, or I've never had this happen, but I know other folks have. The ceramic doorknob cap could be leaky and it's pulling down the high voltage. I'm going to go with the high voltage rectifier yet again and try to pull one out of a working set. Yeah, I've tried 3 different ones or 4 different ones at this point. It seems a little odd that they would all be bad, but I can't see a filament glowing on it. Just checking again right now. I got a pretty good angle, and it's not. Yeah, it's not glowing. It's not glowing. Now there's also, let's check the schematic. Yeah, there's a 2.7 ohm resistor in series with that 1B3 filament. They typically do that to limit the current through it. That resistor could be open, or it could have gone really high in value. Again, it's buried in the damn circuit, so I have to dismantle the high voltage box to check that kind of stuff. Well, as you can see, I have a very bright raster now. I did some more recapping. Underneath, I'd missed 2 caps on horizontal drive area, but there's something really weird going on with this CRT and electron gun. I had to move the ion trap magnet all the way back towards the base because I was seeing a glow inside, and there's still a little bit of a green glow. When I moved it in its normal position, it's a really bright green glow, and at certain positions I was starting to see a little bit of a hot spot on the internal gun structure. So something's not right. I think what's happening is the electrons are hitting the side or some internal gun element. It could be there's a problem with the gun itself and it's damaged, or maybe this ion trap magnet is on the wrong way. I need to flip it around. I gotta check the service info. Or maybe one of the voltages, like G2 or something, is way off. So we're used to the grid and the cathode. Grid modulating it, and the cathode being where electrons come from, but there's also a G2, which is like an accelerator voltage, and it's usually a few 400 volts, something like that. Maybe that's off. I don't know. I've never ever seen that before, a green glow inside. So it's like, well, I just checked voltages on the CRT pins, and yeah, we got a problem. The screen voltage, what I was calling G2, 285, yeah, we're right about there. The cathode, we're a little high, we're around 50, 60 volts instead of 34, but the real problem is the grid. It should be 10 volts, we're 185. So in this configuration, the grid is negative with respect to the cathode, but I have it over 100 volts positive with respect to the cathode. That's really, really, really bad. So that's why I am roasting the heck out of this thing. So what does that connect to? 10 volts. Negative 20, 2.2 meg, 2.2 meg. So it looks like a resistor divider off the negative bus. And then it goes into the video amp. So first thought, of course, always leaky cap, that 0.047, or the 2.2 megs are way out of spec. That fixed the problem. We now have a nice bright focused raster, and the brightness control works, and we have no weird glow in the electron gun. I guess one last thing we'll do before we wrap up this video is feed a signal in and see if we can actually display anything on the face of the CRT. Well, no reception. Part of that is because the tuner is wonky. I've heard these early RCAs have a habit of losing the ball bearing detent for the position indicator, so the knob just rotates smoothly, and no indication of reception. But that's alright. This is a good start. This is a very good start. So I am going to dive in and place more caps and see about fixing that tuner. Now, all of these electrolytics are floating. The negatives aren't connected to the chassis. I shouldn't say they're floating. They're connected to the negative bus underneath. So I'm going to be using adapter caps for all these. It just makes perfect sense because they're all mounted on phenolic wafers and the mounting holes line up. So I'm going to blow through, replace the remaining paper caps and the electrolytics, and hopefully repair that tuner, and then we'll pick up. That's it for now. Thanks for watching.